Hello, welcome back to Statistics and Mathematics YouTube channel. Today I'm going to continue our video on continuous bivariate distributions. In our previous videos, we did introduction to bivariate distributions, and we learned that for bivariate distribution, we are going to consider two variables. For instance, in our slides, we are going to consider what x and y, and then we are just considering that our x and y will be a continuous random variable. If x and y is a continuous random variable, then the continuous bivariate distribution is being defined as you can see here. In our videos or in our discussions on random variables, for random variable we just discussed only one random variable, and then we said that for that one, for a particular random variable, let's say x, to certify to be a continuous random variable, first we said that our f of x, right, our f of x must be what, greater than or equal to a 0. And then if you integrate what, f of x, right, if we integrate f of x with respect to x, the result on the limit, the result must be equal to 1, right? When we come to the bivariate section 2, that's the same thing. Here we are just considering two random variables, that's x comma y. So here our x comma y must be greater than or equal to 0, where the limit of x is being given and the limit of y is also being given. And then if you integrate on both variable x and y of the joint probability distribution, we are supposed to get what, 1 as our result, right? So this is called the joint this is then certified to be what, the joint probability density function of what, x and then y. Okay, yes, so that is the short introduction I can give you. And then we are trying to say that if we are able to achieve this one to be a joint probability density function, then there are some facts here that we have to note. Okay, so we are saying that if a joint probability density function is being given to us, for example, if you get something like our f of x comma y, right, as a joint probability density function, and then for this one we are being asked to calculate for the joint cumulative, right, then say a cumulative distribution function. If you are asked to do that one, how are we going to do that? And that is what this point 1 is going to teach us, right? So for instance, if you are given this joint, right, for us to get the cumulative, we are going to use what, the capital F. This one is for small f. For the cumulative, we are using what, capital F of x comma y. Okay, so here we are going to integrate for the negative infinity, that's from the lower limit of x, right, that is negative infinity to what, the random variable y, and then also integrate from what, the lower limit of x, right, which is negative infinity to what, the random variable what, x, and then we are just changing this x and y, this x and t here, right, so that when we integrate on the limit x and y, we are going to still get a function in terms of what, x and y. That's the main reason why we are changing our x and then y here to what, s and what, t, right? So first we are integrating it with respect to what, x, right, and then the second one we are going to integrate with respect to t. Once you're able to do this one, we will be able to achieve what, the joint cumulative distribution function of what, x and then y. Okay, yes. And the second one says that for values a1 less than s less than b1, and then a2 less than y less than what, b2, right? For this one, it's just giving us what, the limit for both x and y. And if the limit of both x and y is being given to us, and then we are asked to calculate the probability of what, x, the joint of what, the x and the y with the our limit, then you see we can either choose to integrate with respect to x and then come to what, with respect to y, or we can choose to integrate with respect to what, y, before we come to what, x, right? So here the expression here has given us one side. Okay, so we are integrating first with respect to what, x, right? So with respect to s, we are going to get our limit to move from a1 to b1 because our x was also moving from what, a1 to what, b1. That's the reason why we see this one here. And then we integrate it with respect to what, y. That's the second integral, and we are going to get a2 to what, b2, since our y was what, a2 b2. That's the reason why we got what, this expression, right? So don't get worried. We are going to solve more questions for you to better understand. Okay, so the second the third fact that we have to note is that if C is what, a relation of points x and y in a plane where the limit of x and y is being given to us, right? Then if you are asked to calculate for the probability of x comma y, where x comma y is a member of what? The critical region, then what you are going to do is that we are just going to what? Integrate on what? The region. Here we are not just going to focus on the limit here, that we are going to integrate on x and y, but rather we're going to focus on what? The critical region that is going to be given to us for us to solve the question and solve it better. Okay, so I have some question in this slides that work perfectly with the fact 3. So please don't get worried, we are going to solve more questions for you to better understand it. And the fourth says that if a cumulative density function, right, is being given to us, that for in terms of x and y, then the joint probability density function of x and y can be given us. So if a cumulative density function is being given to you, right, and then we are asked to find the joint probability density function, then all that we are going to do is that we are going to take the twice differential of what? The cumulative density function. We are going to do that one with respect to x and then also with respect to what? Y, right? Once you do that, we get your joint. Okay, let's dive into question solving for us to really better our understanding. So our first question says, let x and y be a continuous random variables with a joint probability density function. So this is the joint probability density function being given to us. That is 2xy plus 3 over 2y squared, right? And the limit of x and y is being given to us here. But look, they are telling us to find the probability of what? X plus y less than 1. This is what? A critical religion what question. That is the point 3 that I told you we will solve some similar question under. So this is a typical question under that. Okay, so that is you should find the probability that our x plus y is less than what? 1. So what will be the possible critical region that we will have? The possible critical region that we will have, right? Our c will be equal to what? The limit of what? X, right? 1 less than x less than 1. That is the limit of x. And then we are going to get our limit of y. That is 0 less than y less than 1, right? And then we get our last critical region. That's what? X plus y. That is less than what? 1. Okay, so we have to find the probability, for x plus y less than 1. And then we just learn from our this thing that if you want to find probability, it means that you're going to twice integrate it, right, with a particular limit. That is what you have to do. Yes, that is what this one told us, the critical region told us here, right? As you can see, you are going to twice differentiate it with respect to what? X and y, but we are going to base on what? The critical region to determine the probability. Okay, so as we have it here, we have seen for x and we have seen for y, and we have seen x plus y less than 1, right? So what we are going to do here is that our first integral, right, our first integral, if we are taking our first integral with element of x, we are going to move from what? 0 to 1. That will be our first integral, I mean the outer integral. Okay, and then our second integral, what we are going to do once we take this one, right, we are going to make y the subject here. Okay, so if you make y the subject, you are going to get y is less than 1 minus what? X. Okay, so we are going to also move from what? 0, since the lowest limit for y is what? 0. So you are going to get from 0 to what? 1 minus x of f of x dy dx. Okay, because here was in terms of what? The last one was in terms of y. That is dy. That's the reason I'm having dy here. We can also solve it in this way. You can also choose the y to become first and then just make x the subject here. So what we are going to do is going to integrate from 0 to 1 of integral from 0 to 1 minus y f comma y dx dy. Okay, so that is what we can also do, right? So with these two possibilities, you are going to get the same answer, but I have the solutions on the slides, so let's go there to make our work very simple. Okay, so that is what I was trying to explain to you, right? So they took the second possibility of the integration. That is what we did up there. For this one already, you have already explained it, right? So if you integrate this one, right, we are going to just put in our probability density function. That is 2xy plus 3 divided by 2y squared. That was given to us in the question, right? It was given to us here. That is the joint, okay? It was given to us. So once you integrate this one, first we are going to integrate with respect to x, right? When you integrate with respect to x, there is the expansion you are going to get 1 minus y all squared times y plus 3 divided by 2 1 minus y times y squared dy. And then once you integrate this one, you are going to, if you integrate everything here, you are going to get what? 5 over 24. Okay, so that is the solution to that particular question. Okay, so on the second question, right, we are saying that suppose that x and y represent the operating lives measured in years of components A and B of a certain system, and their joint cumulative distribution function is given by, so here we have been given the joint cumulative density function. And then the first question says that find the joint probability density function of x and y. And here within our fact, we learn here that if a cumulative is being given to us and we want to find a joint of what? Small f x comma y, what we are going to do is to differentiate it with respect to y and also differentiate it with respect to what? We are going to, yes, you can do it other way around. Either you differentiate with respect to y and then later differentiate with respect to x, or you differentiate with respect to x and then later differentiate it with respect to what? Y, right? Once you do that, all of them can also what? Hold. Okay, yes. So let's go into the question solving. So for this one, we are going to differentiate it with either with respect to x and then later and then after that we do it with respect to y, or either with respect to y and later do with respect to what? X. Okay, that is will be for the joint. So let's solve it here, right? So we have this function here, that is 1 minus e raised to the power negative x 1 minus e raised to the power negative y. Okay, so if you are differentiating with respect to x, you are going to get if you differentiate the 1, you are going to get 0, right? And then here is negative 1. When it comes, you are going to get positive, so you are going to get e raised to the power negative x 1 minus e raised to the power y. And with respect to y, we're also going to get the same thing, e raised to the power negative x. This one, if you differentiate, if you differentiate, we are going to get 0. And if you differentiate here, this one come here, you are going to get 1, positive e raised to the power negative y, right? Okay, this is what you are going to get. That one is what? Differentiate with respect to x, and then after that you do it with respect to y, right? You can do it the other way around, and we are going to get the same what? Answer. That is the solution for the first question. Okay, yes. So when we come to the slides, we are getting the same answer as they did. Okay, yes. So let's do the second question. It said find the probability density, find the probability that both components have operating life shorter than 1 year. Okay, both of them. So it means that our x will be less than y, and 1, and our y will be less than 1. Okay, so here when we come, we say that we are required to find the probability that our x is less than 1 and our y is less than 1. Okay, if you do that, since we already have our cumulative density function, right, we can just put in 1 to the cumulative density function to get our probability that our x is less than 1 and our y is less than 1. And if you do that, we are getting our answer to what? 0.3996, because we just have them here. So wherever you see x, you put in 1, wherever you see y, you put in 1 here, and then we get that answer. Okay, and the last question says that we should find the probability that both components have life greater than 2 years, right? Life greater than 2 years. So if we want that one, that means that probability that our x is greater than 2, comma probability that our y is greater than 2, right? For this one, we are doing the normal integration. Okay, yes. So we are going to integrate from 2 to infinity and from 2 to infinity of our joint. Don't go and use the cumulative distribution given here. If we want to find the probabilities, we use the joint PDF. Okay, that's the reason we are using e raised to the power negative x and e raised to the power negative y, and we are doing the integration with respect to x and then with respect to y. Okay, we can turn it and do it with respect to y and then with respect to what? X. Okay, once we do that, we are also going to change the limit, interchange the limit. But here it is fortunate that we are having both our x to be greater than 2 and our y is greater than 2. So if you change it, it will be the same thing. But if in case our limit was to differ, once you interchange it here, you have to also interchange what? The limit here on the integration side, okay? And then for that one, once you do it very well, right, first you are going to differentiate with respect to what? X. And then once you differentiate with respect to x, this is what, integrate. This is what you are going to what? Get here, okay? Yes, this is what you are going to get. And then once you put in the limit, you are going to get our result to be this one. And then our last integration will be from 2 to infinity on that. We are going to get this result, and our final answer will be what? 0.0183. Okay? Yes, that is the answer to that particular question, right? And then we have the marginal probability density function, right? Yes, we have to also know how we will get our marginal probability density function. Sometimes our joint probability density function will be given to us, and then they can ask us, since we have joint of, let's say we have joint of x comma y, they can ask us to get f of x and then f of y in terms of in a continuous case, okay? They can ask us to find this one and then find that one. That is termed as what? The marginal probabilities. So here, that's marginal probability with respect to what? X, and the marginal probability with respect to what? Y, right? So if the joint is being given to us, how are we going to calculate for the marginals? So here, if we want to calculate for the marginal of x, we are going to integrate on the limit of y. That means that we want to remove the y component from it, and then your final result must be only x inclusive, okay? So you are going to integrate from negative infinity to positive infinity of the joint probability density function with respect to what? Y. And then you can be asked to also calculate the marginal probability density function of what? Y. That one you are going to integrate on what? The limit of what? X, right? Times the limit of x of the joint probability density function with respect to what? X, right? Yes. So once you're able to do that, we can get our marginal for both x and what? Y. So let's solve some question to better our understanding on that. So here we said that a random variable x and y have a joint probability density function given by this one, okay? And then the limit is 0 less than x less than y less than 1, okay? And then we have been asked to calculate for the marginal probability density function of x and then y. How can we do that, right? That is very simple. So right now, if we can do that, we just learned that f of x will be given as integral on the limit of what? Y. And then you see that this one, the limit 2 is a joint. This is not a separate limit, it's a joint of both x and then y. So if we want the y is here, so we have to choose the boundary when we turn 1 to the left and then 1 to the right. When we turn 1 to the left, we are getting our lower limit to be what? X, and the upper limit to be what? 1. So we are going to integrate from what? X to what? 1 of the joint, which is 8xy, right? And we are differentiating with respect to what? Y, because we want to remove the y component from it, okay? And for the marginal of what? Y, we are getting integral from, you see here too, we are going to locate what? Our x, right? Because we are going to integrate on x, we want to remove the x component from it. So we are going to get our lower limit to be 0 and our upper limit to be y. So we are going to get 0 to y of what? Our joint. That's x and y, x times y, 8x times y dx. Once we integrate it, we are also going to get our marginals, okay? So I have the solutions here, and once you do that, for this we are getting 4 brackets open 1 minus s squared on the limit of what? 0 less than s less than 1 for the marginal of what? X. And then for marginal of y, this is how we are also going to what? Expand it, okay? We are going to expand integrate from 0 to y, 8xy dx. And then once you do the integration very well, we are going to get 4 times y raised to the power what? Cube. 0 less than y less than 1. That is what you are going to what? Get. For the expectation, we will treat it, okay? So we will not solve that question, okay? Yes, so this is Statistics and Mathematics YouTube channel. If you haven't subscribed, kindly subscribe, like and share, and also don't forget to click on the notification bell so that if I drop any video on probability theorem, you will see and then watch and be helpful to your life. Thank you. Bye. Have a great day.